The overall goal of this procedure is to fabricate and characterize a photonic crystal slow light waveguide or cavity. This is accomplished by first preparing the silicon-on-insulator chip for electron beam lithography by cleaning and spin coating the chip with ZEP 520A resist. The second step is to expose and develop the photonic crystal pattern using electron beam lithography for pattern definition and xylene for development. Next, transfer the photonic crystal pattern into the top silicon layer of the chip by plasma etching the sample in the reactive ion etcher. The final step is to remove the buried oxide layer by etching away the silica in hydrofluoric acid. This creates membraned photonic crystal devices, in other words, devices with air both above and below the silicon photonic crystal layer. Ultimately, the device is optically characterized. If the sample contains photonic crystal waveguides, a Mach-Zehnder interferometer-based slow light experiment is performed. If the sample consists of photonic crystal cavities instead, a resonant scattering technique is used for characterization.
The goal of our work is to study light-matter interaction in photonic nanostructures and to make novel devices and explore interesting concepts in such structures. So in order to concentrate and be able to really focus on the physics of this work, we need a reliable fabrication protocol. We have developed a protocol based on silicon on insulator, which we find very reliable and convenient.